All right, Calculus 30, this is 2.4, number 4. And this one is we're going to use the product rule. And then we're going to also find the derivative by expanding first. And then we're also going to make sure that we understand what this notation is right here, okay? So the f prime means the derivative of the function f. We're given the function f to be this right here. The prime symbol there, the little notch, that means derivative. And when we have a 1 in the brackets there, that means what is the value of the derivative evaluated at 1? If this were if we were to graph this, we would be looking for the actual slope of the tangent line at x equals 1, like at the point on the function where x equals 1, what's the slope? So let's get going by using the product rule. So if we take a look here at this, the product rule says, and I'll write it down here, the product or the derivative of any product can be defined using the factors, two factors. So we're going to go derivative of the first times the second plus the first times the derivative of the second. So that's what we're going to do there. Now, in this case, this is a factor, this trinomial, and this binomial is a factor. So this is going to be f, and this is going to be g, okay? We've got that split up there. So f prime of x, let's find that out first, because we don't want to put the 1 in yet. Let's do that afterwards. So let's find out what f prime of this is. So the derivative of the first is going to be the derivative of each of these separate terms, all added or subtracted together. So the power rule says that the derivative of 6x to the fourth is 4 times 6, which is 24. X to the power of, we subtract 1 from the exponent, it's going to be 3. Everybody okay with that? And then minus, again, 2 times 3 is 6, x to the 2 minus 1, or just 6x. And the derivative of a constant is 0, so I won't even bother putting that in there. Now, we leave the g alone for this first part of the process. And then we always add. So here's where we're at. We've done this, we're adding now. The first factor just on its own without doing any calculus to it, we just rewrite the first factor here. Don't forget the 1. And then we multiply now by g prime, which is, well, 0 minus, minus 3x squared. So it's just negative 3x squared. All right. So we get to this point. Now, I will stop here. If on a test or assignment it says take the derivative, but do not simplify, this is when you can stop, and that's your answer. Okay? Now, for most questions and for most applications, we're going to have to simplify. But for this one, notice this. Before you multiply this all out and expand and gather all the like terms and simplify it as a polynomial, notice what we're asked for. We're asked for the value of the derivative when x is 1. So from this point right here, all you have to do is substitute x equals 1. So I do not have to do any simplification here. I just need to put 1 wherever I see that x. Okay? So that's important. So keep your wits about you when you're doing these questions. Think about it. You don't have to expand and simplify all the time. All right, so f prime of 1 is, that's going to be 24. Well, 1 cubed is all pretty easy, right? 24 minus 6 times 2 minus 1 plus, well, 1 to the fourth, 1 squared, that's all 1. So this is going to be 6 minus 3 plus 1 times negative 3. Okay, because again, I've substituted here, skipped a step, put 1 in for x everywhere. So f prime of 1 is 24 minus 6, what's that? 18 times 1, that's 18. Plus 6 minus 3 is 3, plus 1 is 4, times negative 3 is negative 12. Just flag me if I'm doing something wrong here, if I've missed something. But 18 plus a negative 12 is the same as 18 minus 12, so it looks like 6 here. Looks like 6. Everybody get that? Okay. So that's, yeah, that's A. So B says let's do this same thing by expanding f of x first. So what we're going to do is we are going to multiply here, right? We're going to multiply the first term times every term, the second term times every term, and the third term times every term. And we're going to get this expanded polynomial. We're going to gather like terms, and then we're going to just use the power rule and the sum rule. All right. So we've used the product rule to evaluate the derivative at x equals 1. Now let's expand first, okay? So let's do some multiplication here. So b, I'm going to write this just at the bottom here so I can kind of see what I'm doing. So 6x to the 4th times 2, that's going to be, f of x is going to be now 12x to the 4th when I do this first expansion. And then I got to distribute, right, to each one. So that's going to be negative 6x to the what? What do I do when I have x to the 4th times x cubed? Remember? Do I multiply the exponents? Add them, thank you. So that's 6x to the 7. Is that good? All right, so let's move to the next one now. 3x squared times 2 is minus 6x squared. Negative 3x squared times negative x cubed is going to be positive 3x to the 5. We add the exponents. And finally, plus 1 times 2 plus 1 times negative x cubed. Okay. So this is expanding. And from here, what we want to do is, I guess we could gather like terms if we have any. Do we have any like terms? X to the 4th. We have another x to the 4th? Nope. X to the 7th term? Nope. X squared term? Nope. X to the 5th? Nope. And x cubed terms? Nope. There's nothing to simplify here. So what we'll do is we'll find the derivative now just using the power and sum rule. So I go ahead and I find the derivative of this first term, which is going to be 48 x cubed minus 42 x to the 6 minus 12x plus 15x to the 4 plus 0 minus 3x squared. Very good. Okay, some of you are right along with me there. Okay, and finally, I want to find f prime where x equals 1. So here we go. All of these x's are going to be 1, 1, 1, 1, 1. Whether you square it, take it to the 5, to the 4, to the 3. Yep. Okay, so when we substitute that in, this is just 48 minus 42 minus 12 plus 15 minus 3. So what is this? 48 minus 42, that's going to be 6 minus 12 is negative 6 plus 15 is going to be 9 minus 3 is 6. All right, so when you add up all those, you should get the same value that we got using the other method, and of course we do. And if there was any units or if there was any kind of context in this question, you'd want to make sure you include your units for your answers, but this, no units there. Okay, so that's 2.4, number 4 for the product rule. It's not in your assignment that I gave you the other day, but it is a good question for you to know how to do. Okay.